Hi everyone, welcome back to another video. This video covers capture playback approach and linear scripting approach in section 3.2.2 approaches for automating test cases of the ISTQB TAE syllabus. In the previous video, we have outlined these test automation approaches. In this video, we will discuss the first two options. Let's start with the capture playback approach. In capture playback approaches, tools are used to capture interactions with the SUT while performing the sequence of actions as defined by the test procedure. Inputs are captured. Outputs may also be recorded for later checks. And during the replay of events, there are various manual and automated checking possibilities. Let's check what those options are. The first one is manual output checking. In manual checking, it involves the tester observing the outputs manually to detect any anomalies. For example, imagine testing an e-commerce website. You record adding an item to the cart and completing the purchase. During playback, you manually verify the confirmation message, order history, and total amount charged. The next option is complete output checking. Complete checking requires that all system outputs recorded during capture are reproduced exactly. For example, consider a banking app. When you record a money transfer, during playback, every detail such as transaction IDs, account balances, and confirmation messages must match the recorded output data. The third option is exact output checking. Exact checking ensures outputs are reproduced to the level of detail of the recording. For example, testing a text editor, you record typing and formatting text. During playback, the formatting and layout must match exactly as recorded. The fourth option is checkpoint output checking. Checkpoints checking verifies outputs at selected points in the sequence. For example, testing an online shopping site, you record searching for a product, adding it to the cart, and checking it out. Checkpoints are set at search results, cart summary, and checkout to verify the correctness of outputs at these steps. Let's now discuss advantages and disadvantages of this approach. The biggest and main advantage of this approach is that it's really easy to set up and use. It does not require tester to have programming language knowledge, as the tool which is in use record the interactions and convert those interactions into instructions or scripts automatically. Also, this approach can be used on the GUI elements and the API level. The first disadvantage is that it's hard to maintain and evolve because the captured SUT execution depends strongly on the SUT version from which capture is taken. For example, when recording the GUI level, changes in the element's layout or position on the screen will impact the test script. Another disadvantage is that lack of abstraction. We have actually also identified that this approach lacks abstraction in our previous videos. As for each new test case, tester have to record all steps again. It does not recognize what you have recorded earlier. The third disadvantage is that its implementation depends on availability of fully released SUT. So implementation of the test cases or scripts can only start when the fully released SUT is available. Let's, for example, if you record the script before the release of the software for testing, the GUI elements may change their position on the screen, which in turn will result in failure of your recorded script. So there is no point recording the script before the SUT is released for testers. Let's move on to the next approach. Okay, so linear scripting starts with some manual test procedures. The knowledge about what tests to run and how to run them may be known by one or more test analysts. So there is no formal document. The tester know what needs to be run and how to run it. Similar to capture playback approach, each test is run manually while the test tool records sequence of actions and output from the SUT screen. Recorded scripts may be edited to improve readability or to add further checks using scripting language. The scripts are then replayed by the tool, causing the tool to repeat some same actions taken by the tester when the script was recorded. So just like capture playback approach, it is not a good technique to use where large number of tests are to be automated. And exactly the same issue here, that for each version of the SUT, you have to record these test cases, amend them with manual checks or comments, and then run them. This is the reason that this approach is not considered good for automating test cases. But if you have a small automation task, it can work for you. The only difference between capture playback and linear scripting approach is that editing of recorded scripts. So in this approach, the tester can go and edit recorded scripts, add some more logic to it, or more checks to it, or add comments. Let's move on now to the advantages and disadvantages of this approach. Okay, the biggest and main advantage of this approach is that it's really easy to set up and use, just like capture playback approach, and little or no preparation work required. Well, it does not require tester to have programming skills, as the tool which is in use record the interactions and convert those interactions into instructions or scripts automatically. Learning curve is minimum, and that is specifically for the tool in use. So once TAE have learned the tool, it's simply a matter of recording manual tests and replaying them. The disadvantage is, the first one is that the effort and scalability limitations. Well, the amount of effort required to automate any given test procedure will be mostly dependent on the number of actions required to perform it. That's why the thousandth test procedure will take a similar proportional amount of effort as the hundredth test. In other words, there is not much scope for decreasing the cost of building new automated tests. As we have already actually noted in previous slide, that it lacks abstraction. So when there is no abstraction, that means the previously recorded test cases cannot be used to help the future recorded test scripts. That means we have to record each and every test case separately. The next one is lack of abstraction. Generated scripts lack abstraction. So second scripts performing a similar test with different values would contain same sequence of instructions. The third one is non-modular and difficult to maintain. The scripts are non-modular and difficult to maintain. Linear scripting does not follow common software reusability and modularity paradigms and is tightly coupled with the tool being used. As it's a recording and playback, there is no library in use, or there is no code base which can be reused. So every test case need to be recorded separately and maintained separately as well. So for example, if 10 test cases have similar code and there is a change in GUI, you have to go back and actually modify all those 10 separately. The fourth one is understanding and learning curve challenges. Generated scripts are in programming languages, so non-programmers may find them difficult to understand. Some tools are proprietary programming languages. It takes time to learn the language and become proficient with it. So especially for those team members who are from a non-programming background, it will be an issue for them. Also, the poor documentation in the recorded scripts is an issue. So recorded scripts contain only general statements in the comments, if any at all. Some tools doesn't even add those general comments. So when you look at the script, it will be hard to understand what is going on. Even if you have recorded yourself and you go back after a week or a month, you have to read the code to understand what exactly is being captured and where you have to modify the script if there's an amendment or if there is a change. Okay, this concludes our video, and we have discussed the first two approaches. We'll see you in the next video where the next three approaches will be discussed, which will be structured scripting, data-driven testing, and keyword-driven testing. Thanks for watching. Please like, subscribe, and share, and see you in the next lecture.